Hi everyone! Today we're doing chapter 7.1 on relative frequency and probability. So the question I have is, how do you determine the likelihood of an event? If you were in class for the lesson, we discussed this at length, and we came up with two types of events. Events that have happened in the past, and events that are going to happen or might happen in the future. Oh, spelled future wrong. Off to a good start. Future. Events that have happened in the past come from empirical data. It's something that has already happened. And it's tabulated from past data. A simulation, which we will discuss in section 7.4. Future events are theoretical. Something that will happen or might happen. And we calculate these things, not from data necessarily that's already happened, but from different things that I have already been told. So the big thing is these events in the future, when I calculate these, the likelihood that these events will happen, I'm calculating a probability. While these events, things that have already happened in the past that I have data that I'm using, these are calculating relative frequencies. So here I have note. The term blank should only be used when referring to an event blank. And I'm going to fill these blanks in with the term probability should only be used when referring to an event happening in the future. Oops. I know I'm guilty of this a lot, especially when I taught an Algebra 2 class and I was going mainly off of my textbook. When you have something like a survey that's been asked and you have 100 people and you're pulling from those 100 people, you're pulling from a sample, and I would ask, what's the probability that the person, liked chocolate ice cream in the survey? And I should have been saying what is the relative frequency when I was doing that, not the probability, because this is a survey that's already happened. It's coming from data from a simulation that's been tabulated. So that was actually relative frequency. So those are the two things we're really going to differentiate in the lesson today, the difference between relative frequency and probability. First, we're going to start with relative frequency. So consider the question, how likely is it that a fair coin is flipped and it lands on heads? Well, one approach is to run an experiment. You're going to flip a coin many times and count how many times it lands on heads, or how frequently it lands on heads relative to the total number of times the coin was flipped. The ratio of the number of times the coin lands on heads to the number of times the coin was flipped is called the relative frequency. Now, frequency refers to the number of times an event occurred. Relative frequency is the ratio of the number of times the event occurred to the total number of trials in the experiment or the simulation. So therefore, since I have these two things, I can define relative frequency. So relative frequency of some event is equal to the number of times the event occurred all over the total number of trials. I'll often use RF in order to denote relative frequency. So let's look at an example. A fair coin is flipped 10 times and the results are pictured below. So you can see my first flip, it landed on tails. Second flip was heads. Third flip was tails. Fourth flip was heads. The next one is tails, tails again, heads, tails, tails. So the frequency of tails looks to be that it happened 1, 2, 3, 4, 5, 6, 7 times. The relative frequency of tails is 7 over 10 total trials, or 0.7, or I could say 70% if I want to express it that way. Let's say you're going to make a bet about what the next coin flip would be. Based on the results above, what do you think is most likely to happen in the next coin flip? Heads or tails, and why? So in class, you guys had a lot of different ideals. A lot of people said, I'm going to pick tails because it looks like that's what's happened more times. I'm going to go with my relative frequency. And some of you said, it really doesn't matter what I pick because the likelihood of a head flip or a tail flip is 50-50. A lot of y'all said 50-50. And we talked about how you're getting that 50-50 from a 50% chance, or the probability being a half of the coin flip. So you guys already have an idea of probability that you're using to determine your decision, regardless of what this data told me right here with these 10 coin flips. Now let's look at my next question. Mrs. Schenkel shot 10 free throws, and the results are recorded below with a check meaning she made the free throw and an X meaning she missed the free throw. So the frequency of tails is, so not tails, let's say the frequency of a shot made is, so I take a look, it looks like she made 4 in a row, missed the next 2, made another one, missed 1, made 2. So it looks like she made 7 total. So the relative frequency for a made shot is 7 out of 10, or 0.07, or 70% chance again. So let's say you're going to make a bet about if Miss Schenkel is going to make or miss the next free throw. Based on the results above, what do you think is most likely to happen in the next shot and why? And in class, you guys quickly pointed out that this is a different scenario because you guys say there's some skill involved. You would probably bet that I would make the next free throw because I made 7 out of 10, and that is a higher chance than 50-50. This 50-50 comes up again. You know that the probability of making a shot is a 50% chance, or 1/2, because I'm going to make it or I'm going to miss it. There's only 2 outcomes. However, you guys said there's skill involved in making free throws, and there's no skill involved in my previous example of my coin flip. So here you said you're not going to make this bet at all. It's 50-50, and both outcomes are equally likely. Yet here you said you're going to use this data, this relative frequency, whenever you make your bet on whether I'm going to make the next free throw or not. Frequency of tails, very insightful. So now that leads us into probability. Let's consider the same question. How likely is it that a fair coin is flipped and it lands on heads? Assuming an evenly weighted coin, there's 2 equally likely outcomes. You can flip and get tails, or you can flip and get heads. Probability is defined as the ratio of the number of outcomes that meet the criterion to the total number of equally likely possible outcomes. Therefore, if I were to flip a coin, I can list what's called my sample space as flipping and getting a tail, or flipping and getting a head. Those are my two outcomes. And the probability that a coin is flipped and it lands on heads, I can look and I can see it happens one time out of the two equally likely outcomes. So the probability is or 0.5 or 50%. And now comes the fun part. So if you are not in class, this is going to be your assignment. This is what everyone else is doing. You're going to be you rolled a 6-sided die in class to determine which team you're going to be on. And I feel like this should be die. If you rolled a 1, 2, or 3, that means you're on team 1. And if you roll a 4, 5, or 6, that means you're on team 2. And you need to keep it a secret. Don't tell anyone what team you are on. Mrs. Schenkel is going to be guessing who's on team 1 and team 2 after reviewing your data in the next class. So now let's talk about what happens once you're on one team. If you're on team 1, you are a real flipper. You're going to flip a fair coin 100 times and you're going to record your result in an Excel spreadsheet or a Google sheet to show me. You can just denote a head with an H and a T with a tail, or a tail with a T. Team 2, you are going to be a fake flipper. You are going to pretend to flip a coin 100 times, and you're going to record your results in the same fashion as team 1. A capital H for a head, a capital T with a tail. I know it sounds ridiculous, but I want you to actually pretend to flip the coin and pretend you see it, and not just randomly do H's and T's. Although you're welcome to do that too. It's up to you, but it makes it more real if you fake flip the coin. When you come into class, what you're going to do is show me your data. I'm going to glance at your data, and I am going to predict if I think you were a real flipper or a fake flipper, giving us two sets of data. We're going to have all of our heads and tail data to work with, and we're also going to have how correct I am at guessing. So we will tabulate if I get it right or if I get it wrong. And so we'll see how good of a guesser I am. And that should be fun. 1/2. In summary, what we've got is we have got relative frequency versus probability. Spell often? Lity. There we go. So let's remember that relative frequency comes from events that happened in the past. Relative frequency is going to be a number that ranges from 0 to 1. 0 meaning it didn't happen. 1 meaning it happened every time. And these things happened in probably an experiment. You've got data from usually a simulation that you're working with, that you're using to determine these relative frequencies. Whereas probability is coming from an event that's going to happen in the future. Probability also is going to range from 0 to 1. Same thing, 0 meaning it will not happen, and a 1 meaning it is going to happen every time. So that's the big summary of today, relative frequency versus probability, those big ideas. So now you are set to do problem set 7.1 on top of our experiment, and we come into class, I will start looking over your data and guessing who is a real flipper and who is a fake flipper.